Hi guys, welcome back to 30th video tutorial of J2EE. In this tutorial we are going to discuss about a very important topic which is about the single thread model interface. So before we get into this, let me tell me the problem and then we can discuss how this particular interface will resolve the particular problems and what and all other code we have to optimize by using this particular interface. So what and all other things we can avoid. So let me describe a problem now. So let's assume there is a ticket booking system. So the very popular one is IRCTC, which everyone knows. Let's assume this is our IRCTC application, which is there in server. So here we implemented a set of servlets like booking ticket servlet. So the one of the servlet I'll tell is, but it's not coming. So there is a servlet called login servlet, and we'll be having one more servlet called book ticket. So book ticket servlet. Suppose let's assume there are two servlets are available within IRCTC app. One is login servlet and the other one is book ticket servlet. So the purpose of login servlet is to make user authentication proper. The other servlet is like booking tickets from booking tickets purpose it is used for. And let's assume our database. Let's assume these are database and there is a table within the database named so and I'll be taking one table within that. So I'll name this table as IRCTC tickets. So these is the table I'll be declaring. So within this table there are tickets, number of tickets. So before getting the booking started, so the number of available tickets I'm just telling. So for different locations, let's assume for Hyderabad to Tirupati. So there are 5 tickets available at the whole. So for it's not be 5 always, and it will be more than 5. But for demonstration, I'm just giving the 5 tickets available. So for Hyderabad to Tirupati, we have 5 tickets. Let's assume the other location I can tell Hyderabad to Bangalore. Let's take there are 10 tickets available. Let's assume these are the 2 records we have in the database, and one is Hyderabad to Tirupati. We have 5 tickets available, and the other one is Hyderabad to Bangalore. There are 10 tickets available. Let's assume these are the 2 rows we have in the IRCTC tickets table, and there are different clients are trying to access this particular IRCTC application to book their tickets. Let's assume these one of the client. Let me take copy. So there are three different people are trying to book the tickets from three different machines, and they will be calling the same servlet. And the first user, he will be trying to book the tickets for Hyderabad to Tirupati, and he'll be needed two tickets. I can mention TPT or Tirupati. He need two tickets. And the other guy, he is actually required for Hyderabad to Tirupati. He need three tickets. And other guy, he need Hyderabad to Tirupati. He need one ticket. So there are three different. It's going to. Let me write it more clear. So this guy need Hyderabad to Tirupati. He just need one ticket. So likewise, people are requesting, and I'll give the priority for these users. So this particular user, so this is the first request, and this is the second request. So he requested one at first. So he is the first guy who made the request to the server, and he's the second guy. Or I can give request number 3. Let me keep it 3, and I'll give this to 2. Request number 2. So I'm just giving in order, like these the first request, it comes to the server, and the second request comes to the server, and this is the third request. This first person, he needed 2 tickets, and the second person, he need 3 tickets, and the third person is need 1 ticket. The overall the tickets are required for all the users is like 2 plus 3 plus 1, which is 6 tickets. Total number of tickets required is 6, but available tickets so required for HYD to TPT is 6, and available tickets for HYD to TPT is 5. So people are requesting one ticket more, but which is not available in the system. So there are 5 tickets only available, but we need only 5. They need 6 tickets, but we have only 6. We have only 5 tickets available in the system. What will happen is, whatever the request comes first, so that request has to go to the server, and we have to check the availability. Suppose first request is coming to the server, and what will happen is the request 1 goes, and it will check the database and whether how many tickets are available in the system. So it depends on the availability, it will get the resources. So until it get the resources, means it until it serves for request 1, it won't allow other users to continue. Like suppose request 1 is coming, and he needs 2 tickets. What will happen is system will allow only request 1, and once it is 2 resources is allocated, then only request 2 and followed by request 3 will execute. By that time, So when the first request comes, this will be active, and request 2 and request 3 will be in hold. So it won't process the other request, even whatever the request, how many they need, and then it will check for second request saying so once this 2 allocates means out of 5 how many the remaining will be 5 minus 2, which is, so 2 is gone, so we have only 3 left. And the second request come, so once this is process is done, then it release the hold. So this will release the hold. Once the releases hold, the releases, then the third, the second request, the number of seats 3. So it will check whether the available 3 tickets are available or not. If it is 3 is there, then allocates. So what will happen till that time, till request 1 and request 3 is completed, request 3 will be at hold position. Now it will check how many tickets will be there. 3 minus 3 equal to 0. So there are no tickets available once the request 3 comes to the picture. What will happen, even if he requested for 1 ticket, it will actually fail to allocate, saying no tickets available. So these are our IRC system will perform. So to maintain that, like putting the holds and releasing the holds and allocating the resources, like limited resources, how many are there? So this entire thing we can do it using thread synchronization. So thread synchronization we can able to achieve using synchronization blocks or synchronization methods and synchronization classes. Mostly in the industry, like what people are using to synchronization methods will be like synchronization blocks or methods. So one of the approach we have to choose to make this synchronization happens means to make the resources synchronized. So either of one we have to choose and we have to maintain this code. So writing a synchronization blocks or synchronization methods, guys, if you're not aware of what is synchronization block and what is synchronization methods, please go through my core Java tutorial. There you have a clear picture how we can maintain a synchronization and how to achieve all kind of synchronization stuff. I have given examples over there, and so I'm just briefing here. I'm not explaining the synchronization code and all. I'm just giving the brief about how synchronization works. So in this particular scenario, to maintain the resources, like limited resources to be served to the particular users, so whatever the request comes first, so those has to be served first, and whatever the request comes last, so depends on the availability, it has to serve, otherwise it has to give, it won't allocate any resources, it will fail to allocate the tickets if it is not available. So likewise, to maintain the code, we need to have a synchronization, which is thread synchronization. So writing a synchronization methods and synchronization blocks within a servlet, it's not much recommended, because this will makes our application not much stable, and maintaining code also it's very hard, and we need to be very much careful writing these synchronization blocks and synchronization methods, and until unless if you're pretty much strong enough in multi-threading, you cannot touch this point in your servlets. So to avoid these kind of expertise requirement in servlet programming, so there is a new interface introduced, which is SingleThreadModel interface. With this, you just need to implement this interface in your servlet, and that's it. Then your servlet will work like a synchronization way. Like suppose if you are writing a book ticket servlet in your project, so there you just need to you know how to create a servlet, right? Creating a servlet means by extending HTTP servlet or generic servlet, or you can implement the servlet interface. So once so by this way, if you can able to implement your servlet, and after that, the additional step you have to do is you just need to implement your servlet to single thread model. So what are the servlet you have out over here? For that servlet, you just need to implement this particular single thread model servlet. You just need to implement this single thread model interface. That's it. If you does that, then by default that will treat as the thread synchronization block. So for demonstration, I'm just giving, suppose if you have this particular servlet, or you can take any servlet like save products, or any servlet. If you take, suppose this, you can treat it as your what is the servlet name here, book ticket servlet. So suppose if you treat this one as a book ticket servlet, and then you just need to implement single thread model. That's it. If you does that, then that's it. This is deprecated because of the version of Java, so don't worry about that. And you just need to write suppress warnings that will allow you to put that. And you just need to implement the single thread model that will actually makes you your class booking ticket servlet class to be synchronized. So you don't need to write synchronization blocks and synchronization methods, and you don't need to particularly handle those things in your hands. The simplest way is you just need to have this knowledge, and that is the purpose. I'm just giving the diagram in clear picture so that you can understand better. And you just, for the servlet, there is no much code you have to implement. You just need to create a servlet by extending one of the servlet implementation like HTTP servlet, and on top of it, you just need to add implements single thread model. So once you add it, that's it. Your class becomes the synchronization way, and that means that the single thread model way, like this will actually only one request will comes to this particular servlet. So the other request, like this request 2 and request 3, will be hold until this request 1 serves properly. So once request 1 is completed, then only it will take the request 2. That's this default functionality will be implemented within the single thread model interface. So that's about this, guys. So in your you will be getting very rare situations to implement that, but make sure if you're getting these kind of situations, like the number of resources are limited and that has to serve to the request basis and the priority of the request basis, and that case you can use the single thread model interface implementation in your servlets. So thanks, guys. Thanks for watching. In next tutorial, we're going to cover very important topics. So session tracking, how can we do the session trackings, and what are the methodologies we have in session tracking, and these things we can discuss in next topic. That will be a very much interesting topic, and that we can see it in practical, and there we can have some kind of login pages and all. So let's wind up this tutorial, and next tutorial we can meet it. Thanks, guys. Thanks for watching.